Hi guys, just doing another post. Again, this is going to be a YouTube one. Hopefully it works a lot better. Let's continue. Alright, last step we got up to was our flywheel, and looks like we have center drilled it. Hasn't gone in very deep. I've just gone in normal center drilling depth. Normal center drilling depth. Oh, there we go. Looks better. Not into this section where your live center would normally mount, but just in that depth so you can drill the next hole. Alright, our next hole is, according to our sequence up here, it says it's we've done a center drill, 3mm drill bit. And I've got the two options here. I've got the box with them too actually, so you can see what's going on here. So we have our Viper series from Sutton, and we have the Blue Point series from Sutton. Blue Point ones here have this blue coating on them. It's supposed to be a dry lubricant, and these Sutton Viper series ones look very shiny, but they have what looks like a heat affected area on the tip there. You can see. See that hot area up on the tip there. Now, I had a look at some of the Sutton websites, and they're saying that the Viper Series one, the Viper Series drill bits, are doing about an extra 10% work before they go blunt in comparison to the Blue Point ones. So the Blue Point sound like they're the obsolete version now. These sound like a better drill bit, which I was surprised to see. So yeah. Blue Point, not so good anymore. Viper Series ones with the heat affected end sound like the better one. Now I think there might be an issue where if you have used this a few times and sharpened it a few times, then maybe it would be outside that heat affected area or short of that. And when you sharpen it again, maybe it wouldn't be as hard and it wouldn't last as long. I couldn't find any details about that. But at the moment it's full length, so it's according to their analysis, these ones last longer than these ones. Alright, anyway, we can't use these ones because they recommend not using Blue Point series drill bits on any non-ferrous materials. Brass, bronze, aluminium. We're doing aluminium, so we don't want to use that 3. We want to use the Viper Series 3. Let's grab that. Mounted our drill chuck into the tailstock quill, tighten that up just by hand, slide that along, clamp the tailstock clamp, with our safety guard down, reset button off, switch the green button, you would have heard the relays click then. Back over here where we could run this a lot faster. I'll run it a bit faster just so you can see what the sound is. At the moment we're set at, this one points down to this one, and we're in the C column, so we're at 770. Let's increase that to 1100. B column, still pointing to the lowest line, and we're in high range, low range, so we're at 1100. Let's start it up and we'll see if it makes too much noise for the video. That's what that says. A little bit higher. Let's go back to 770. I think we'll stick to 770. 1100 just sounds too noisy. Oh, here we go anyway. So I'm using a really light touch here to actually wind this coil out. It takes no force at all. On a nice sharp drill bit, it should be just pulling its way through almost. Through. That was through 20 mil of aluminium in 15 seconds. So a quick look at that. Even though this is soft aluminium, it is still quite sharp, so just be careful when you're removing something that's swarf all over it. Here, we'll just have a look. I did actually cut myself this morning on something else, so there's always sharp stuff around the place. So just be careful when you're removing this sort of stuff. Gloves are not ideal because you don't use gloves on any machine in the spindle. Oops, sorry, I probably shouldn't have just chucked that down the floor. Let's put it back over here, in behind the swarf tray. Alright, no real marks on that drill bit. Oh, sorry. May have lost a little bit of that colour. May have lost a little bit of that colour, but it doesn't have quite the same. But that's just wearing a bit of surface colour on it. It'll still be the same hardness underneath all that. Right, next one. Next one says to 6 mil drill bit. Again, I've got our two options. Blue Point series and the Viper. Oh, this isn't actually a Viper series. This is another one of Sutton's, I believe. Yeah, you can probably see where it said. I'll hand over it. Oh, still doesn't like it. Oh, there I can faintly see Sutton down on the shank anyway. Well, there you go. It's got. You can see the 6.0 and the start of an S. Can kind of make out Sutton in there if you have to. So another Sutton one, but this is a different series, series of drill bits. It's not the Blue Point series, and it's not the Viper series. This was another cheaper series they've done, just their standard one. So it's basically a Blue Point one without the Blue Point coating. So they're cheaper range, but they still cut quite well. Now I just sharpened that too before the video. Sorry, I sharpened that just on a bench grinder, so it's nice and sharp. Corners aren't funky. There's no issues there when I run my finger along that sharp cutting edge there. Yeah, it's quite sharp. You should be able to see that on the video there. It looks pretty good. Both sides. Nice and sharp. Alright, let's give that a run. Now, just before we go any further, I just want to make sure I'm not going to ruin this drill bit by running it too fast. So let's go to our speed and feed chart and just do a quick check. Make sure we're going to run this at least below its correct speed. Right. So on our chart, we are, it's called a nomogram, lathe speed and feeds. Now we're drilling with the lathe and we're using a high-speed steel drill bit. And in amongst here, you'll be able to see mild steel. This one's hard to read, but it says mild steel FC. You don't want the FC one. FC means free cutting, which we're not really doing. We want to pick the one just below. So below the FC, mild steel FC, we want to pick this mild steel one. We have to look along that line, we go along. About here we start getting, that's number 12. We only have a 6 mil drill bit, so that's number 10. That's number 6 there. So number 6 above that line. So we want to go across here now where they two intersected, and we can run that at about 1200, 1200 RPM. And we're only running it at 770. Slower doesn't matter, it won't damage the drill bit, it just takes longer, but faster will damage things. So let's change this over, let's put her in. Stick with the 770, mounted that up, lock our handle again, and again we should need no more than one finger of pressure. that tailstock handle wheel, just one finger. I'm really not pressing very hard. Sorry, the swarf coming off it is looking quite good. And that's it, I'm through. Again, I need about 15 seconds. I'll take that out. I'll have a quick squeeze, we're kind of finished now. Now, one other thing I could do before I take it out, again I should have been careful with that then, but no gloves, just got to be careful. I could have used, I couldn't use a magnetic tool to drag it away because aluminium as it is magnetic. I could have used a ruler or maybe even the verniers, preferably not the verniers, but a ruler would be good to drag swarf away like that. Now, that's fine, that's done, that over there. I don't want to take it out just yet. I want to deburr my hole. So on the end of that flywheel block there, it doesn't feel too burred, but I just want to deburr it anyway. It's a good habit. You should always be deburring stuff. Doesn't matter if it's just you using it or whether it's a customer that's you're providing something to and making sure it's deburred. Either way, we're going to give it a little countersink. Now we can do this two ways with countersink. We can, because it is so soft, we could just put it on the end here and push it around with our fingers with a little bit of force, and that's all it takes. You guys can't. Second. See the aluminium swarf. It's not going to focus on it. I did take up aluminium swarf anyway. It's on that countersinker, and that feels much better. You can probably see the slight cut from it. So, yeah, you guys can see that shiny edge where I have actually chamfered it. So chamfer is a 45-degree angle, and that little cut that I've taken on there is that little 45-degree angle. Went all around the outside of the hole there and remove the burr. Now this is the side that wouldn't really have much of a burr anyway because we were drilling from this side. Let's spin it over and do the same thing and see what's happening with the other side. I need to start setting a timer on my phone so I only run for 15 minutes. Alright. So on this one, we had way more burr. You guys can clearly see that burr sticking out. If I ran my finger over it, I would cut my finger if I put too much force on that. So let's get that burr off. Now with this one, I'm going to remove it with the countersinker, but I'm going to put the countersinker into the tailstock chuck. Push the whole tailstock forward, lock the handle, guard down, light on, forward position. I don't want to take too much out here. I just really want to get rid of that burr. I'm leaving a really slight countersink. Set the fly off it. That's it. Now I haven't asked you to do this in the plans. It doesn't say anything about countersinking, but it is a very good idea. One, for safety, and two, you'll find out later on that when you do the step shoulder from the 6.12 up to the 8mm, there'll be a little bit of a radius, and that radius will slot into that little undercut area a lot better. Alright, that's done, guys. That is our. Let's take it out. Have a quick look. That's our aluminium flywheel completed, deburred, with that chamfer, all ready to go. We'll be going for 15 15 minutes. I think we'll stop that at that, guys, and I'll do another 15-minute demonstration shortly.